Good morning everyone. In this lecture we have to see about the objective of structural design. Myself, Dr. J. Sahaya Ruban, Professor and Head, Rohini College of Engineering and Technology, Kanyakumari. The objective of structural design. The objective of structural design is to be design of structure for stability, strength, serviceability, finally economical. The design of structure should satisfy these four requirements. So stability, nothing but it will prevent the overturning, sliding or buckling of the structure under the action of external loading. Strength is it is to resist the stresses induced by the load in various structural members. Serviceability is it is a satisfactory performance under service load condition, which implies providing adequate stiffness and reinforcement to contain the crack width and vibration within the acceptable limit. Also provide impermeability and durability. So finally, the economical, it is indeed a challenge and a responsibility for the structural designer to design a structure that not only a good appearance but also strike the right balance between safety and economy. Steps involved in RCC structural design process. The entire process of structural planning and design requires not only a imagination and the concept or conceptual thinking, but also sound knowledge of practice and practical application. Design of any structure is categorized into two main types. First one is a functional design, second one is a structural design. We have to see the functional design and the structural design in briefly. The functional requirement of design of structures. The structure should be constructed to serve the basic purpose for which is to be used. It is a pleasing look, a happy environment inside as well as outside. It has a good ventilation property. Lighting and acoustic should be provided in a proper manner. For community halls as well as cinema theatres, it is in an unobstructed view. These are the basic functional requirement of the structure. Structural design is an art and science of understanding the behavior of structural members subjected to loads and designing them with the economy and elegance to give a safe, serviceable and durable structure. The stages of structural design. The process of structural design involved in following stages. First one is the structural planning. Second is the action of forces and computation of loads. Method of analysis. Fourth one is a design of members. Finally, detailing, drawing and preparation of schedules. The types of load on structure and loading combination. Indian Standard Code IS 875 1987, Part 1, Part 2, Part 3 and Part 4. The minimum design load for building and other structures specify various design load for a building and the structures. The types of load acting on the structures are dead load or the self weight of the member, imposed load or live load, wind load, snow load, earthquake load and the special load. So these are the load normally act on any structures. Let us discuss the loading one by one. First one is the dead load. The first vertical load that is considered is dead load. Dead load are permanent load which are transferred to the structure throughout the lifespan. The calculation of dead load of each structure are calculated by the volume of each section and multiplied by the unit weight. The unit weight of the sum of the common material presented in the table. For the brick masonry, the weight is 18.8 kilonewton per meter cube. For the stone masonry, it is 20.4 to 26.5 kilonewton per meter cube. For a plain cement concrete, it is 24 kilonewton per meter cube. For a reinforced concrete, 25 kilonewton per meter cube. Timber having a weight of 5 to 8 kilonewton per meter cube. Next one is a live load or imposed load. The second vertical load that is considered in design of structure is imposed load or live load. Live load are either movable or movable loads without any acceleration or impact. The minimum value of live load to be assumed are given as IS 875 Part 2 1987. It is depends upon the intent use of the building. Next one is the wind load. So wind load is a primary horizontal load caused by the movement of air related to the earth. The calculation of wind load depends on the two factors. First one is the velocity of wind and next is the size of the building. The complete detail of calculating wind load on the structure is given by IS 875 Part 3 1987. The design wind velocity Vz is calculated by the following expression. Pz is equal to K1 into K2 into K3 into Vb. K1 is the risk coefficient, K2 is the coefficient based on terrain and height of the structure, K3 is the topography factor. This is find out from the IS 875 Part 3. The design wind pressure is calculated by Pz is equal to 0.6 into Vz square. Next is snow load. Snow load constitute to the vertical load in the building, but these type of loads are considered only in the snowfall places. IS 875 Part 4 1987 deals with the snow load on the roof of the building. The minimum snow load on the roof area or any other area above the ground which is subjected to snow accumulation is obtained by the expression the S is equal to mu into S naught, where S is the design snow load on plan area of the roof, mu is the safe coefficient, S naught is a ground snow load. Earthquake forces constitute to both vertical and horizontal forces on the building. The total vibration caused by the earthquake may be resolved into three mutually perpendicular directions, usually taken as vertical and two horizontal directions. The moment in which vertical direction do not cause forces in superstructure to any significant extent. But the horizontal movement of the building at the time of earthquake is to be considered while designing. IS 1893-2014 gives the details of such calculation for the structure standing on the soil which will not considerably settle or slide due to earthquake. Apart from basic load, some of the other loads also acting on the structures like foundation moment, elastic axial shortening, soil and fluid pressure, vibration, fatigue, impact and erection loads. Loading combination. A combination of load occur when different types of load act on the structure simultaneously or acting together. To avoid failure in a structure, a load factor is to be used in case of combination of load acting on a building. In a codal provision IS 456-2000 give clear loading combinations based on that structure should be designed. We have to find out that loading combination. The design should be done for the worst loading combination. So that is a procedure normally we follow for a design of structure. Thank you so much.